For the longest time, when you talked about how powerful a computer was, you were really just talking about one thing, right? The CPU. Well, that era is completely over. Suddenly, we're hearing about GPUs, TPUs, DPUs, even QPUs. It's a whole new alphabet soup of processors, and trust me, understanding it is the key to seeing where technology is headed next.
So what's the deal? Why this sudden explosion in all these different kinds of chips? It's really because the jobs we're asking our computers to do have fundamentally totally changed. Powering massive AI models, running global data centers, these are tasks so specialized that one all-purpose brain just can't handle it all anymore. We've officially entered the age of the specialist.
All right, so here's how we're going to break this all down. We'll kick things off with that processor alphabet soup, and the one we all know, the CPU. Then we'll meet the new specialists on the block. After that, we're going to zoom out to see the huge global race this has started before taking a little peek over the horizon at the wild world of quantum computing. Okay, so to really get what's happening now, you got to look back at how things used to be. And for a long, long time, the world of processors was, well, it was a surprisingly simple place. It was really all about one big rivalry. I mean, for as long as most of us can remember, it was just Intel versus AMD. That was the whole game. You picked a side, you bought their chip, and that was that. They were the two giants battling it out to be the brain inside every single PC. And that classic rivalry, it's more fascinating right now than it's ever been. So you've got Intel still the king of volume, shipping the most chips overall. But AMD, they're playing a totally different game. They've pulled off this brilliant strategy, targeting those high-end, super profitable markets. And the result? They're grabbing a bigger and bigger piece of the actual revenue pie. It just goes to show you the chip race isn't just about volume anymore. It's about value.
And that brings us right to the heart of the matter, the CPU itself, the versatile, do-it-all brain that has powered our digital lives for decades. But even this incredible generalist is now staring down challenges it was simply never designed to handle by itself. The absolute best way to think about a CPU is to imagine it's a brilliant family doctor. It's incredibly smart, super flexible, and it's designed to handle a huge range of problems you throw at it, one after the other. It really can do a little bit of everything. And this is exactly where that whole model just falls apart. The rise of AI, of machine learning, of these massive data analytics problems. It's like asking that one family doctor to perform thousands of highly specialized surgeries all at the same time. The generalist working one task at a time just can't keep up. The scale of the work has completely changed the game. And that's where our specialists come in. This massive demand for doing tons of things at once created an explosion of new kinds of chips. But here's the really important part. These are not CPU replacements, not at all. Think of them as a team of experts working right alongside the CPU, each one custom-built to solve a very specific problem with incredible speed. All right, first up, the one you've probably heard of, the GPU, the graphics processing unit. You definitely know it from the world of gaming. It was born to render these beautiful, complex 3D graphics, which means doing millions of simple, repetitive math problems all at once. And it turns out that one skill, doing things in parallel on a massive scale, is exactly what you need to train modern AI. So the GPU became our surgeon, performing thousands of similar operations all at the same time. This absolute mastery of parallel computing is precisely why the GPU became this, unexpected hero of the whole AI revolution. It's now absolutely essential for everything from making your games look amazing to training those huge language models we're all talking about. So if the GPU is our surgeon, then you can think of Google's TPU as the neurologist. It's an even more specialized chip. It's what's called an ASIC, which basically just means it was designed from the ground up with one job, and one job only, to speed up the very specific kind of math that's at the heart of neural networks. And that laser focus, man, it pays off big time. TPUs are just ridiculously energy efficient when you're working at a massive scale. These are the chips that were behind Google's groundbreaking AlphaGo victory. They're the ones processing text on Street View, and they're the powerhouses helping to refine your Google search results every single day. Okay, so our final specialist tackles a totally different kind of problem. While GPUs and TPUs are all about computation, the DPU, or data processing unit, is all about managing the insane flood of data inside a modern data center. It's the hospital administrator, handling all the critical but boring jobs like networking and security, which frees up the CPU to focus on running your applications. You might not think about them, but in today's cloud-first world, DPUs are absolutely essential. They are the silent heroes that make sure all that data moves around quickly and securely, freeing up precious CPU cycles and just making the entire data center run way more efficiently. This is crucial for cloud providers, 5G networks, you name it. So, if you take just one thing away from all this, let it be this. Modern computing is a team sport, period. It is no longer about one chip trying to do everything. You've got the CPU as the family doctor, the GPU as the surgeon, the TPU as the neurologist, and the DPU as the administrator. It's all about using the right specialist for the right job. Now, this massive shift from a single hero processor to a whole team of specialists, it hasn't just changed our computers. It has kicked off an unprecedented, absolutely insane global race. And this competition isn't just between companies anymore. It is now a matter of strategic national importance.
If you want to get a sense of the sheer scale of this new race, just look at this number, $251 billion. That's what just 4 companies, Amazon, Google, Meta, and Microsoft, are spending on infrastructure in a single year. And that staggering amount of money, it's almost entirely dedicated to building out massive data centers, just jam-packed with these powerful new specialist chips. But here's the real game changer. These giants aren't just buying these chips off the shelf anymore. They're designing their own. We already talked about Google's TPU, but now Amazon has its Trainium chip, Microsoft has its Maya AI chip, and its Cobalt CPU. This is a total power play. It's about controlling their own technological destiny, right from the silicon up.
And this corporate arms race you see happening, it's being mirrored at the national level. Access to cutting-edge computing power is now seen as a critical strategic asset, just like having access to energy or having a strong military. Nations and entire trading blocs are pouring billions into this, all to make sure they don't get left behind in this new technological frontier.
Okay, so if this team of specialists is the here and now, what's next? What comes after this silicon explosion? Well, the answer might force us to completely rethink what a computer even is. Meet the QPU, or Quantum Processing Unit. This isn't just a step up, it's a completely different kind of thinking. Instead of our normal computer bits, which are either a 0 or a 1, QPUs use something called qubits. And here's the mind-bending part. Thanks to the weirdness of quantum mechanics, a qubit can be a 0 and a 1 at the exact same time. This allows it to process a ridiculous amount of information simultaneously. The potential here is... it's almost hard to wrap your head around. QPUs could solve certain types of problems that are literally impossible for even the biggest supercomputers today. We're talking revolutions in drug discovery, creating new materials, breaking modern encryption. But here's the reality check. The technology is, well, it's basically in its infancy. These quantum systems are incredibly fragile, super prone to errors, and just astronomically expensive to build and operate. So the trend is crystal clear. We've moved from a single soloist to a whole orchestra of specialists. The CPU is still the conductor, sure, but it needs its ensemble of GPUs, TPUs, and DPUs to create the symphony of modern computing. Which brings us right back to that alphabet soup and leaves us with one final thought. What impossibly complex problem is out there right now just waiting for a brand new processor with a brand new name to be invented to solve it?